When I have something that is unclear to me, I like drilling into that subject, finding out what's at the bottom of this. I also like that there's different aspects to my work. So it's very good for me that I can switch in between different things and have some sort of variety, so to say, in my work. So my name is Leon. I'm a doctoral candidate at the School of Natural Sciences. I started studying physics in 2015, and I have been here ever since. Right now, the place that I'm doing my PhD at is the research reactor in Garching, and I work with antimatter, particularly with positrons. I chose TUM because I like Munich. I also like the proximity to the mountains, and there's a lot to do here. I also knew that TUM was a good university, especially for like the hard sciences like physics and chemistry. And I was sort of drawn here. So I'm doing material science, defect spectroscopy, looking into how aluminum alloys, the material properties change depending on defect, and also doing simulations about this. We are here at a research reactor. What we do is we take the neutrons that are generated also by the nuclear reaction. You can do very interesting stuff with it. If you shoot neutrons onto materials, they react in certain ways. For example, they can get deflected by the material or refracted. This way you can analyze structures of materials. Behind me is the experiment that I work on. Usually we bombard the sample with positrons from above. The positrons annihilate and they release radiation, and we measure that radiation. This radiation gives us information about the material. The detectors that detect this radiation, they have to be cooled to very low temperatures. So we use liquid nitrogen to cool the detectors. This is not only unique in Germany. In fact, there's probably only less than a handful of this kind of experiment in the entire world. I'm responsible for obviously doing my measurements, but I also have to keep the experiment itself in working order. We are operating at a large research facility, which is publicly funded. And part of that is always that you have something called user operations. That's scientists from all over the world. They have something that they think might be interesting to investigate here. And they bring us those samples, and then they do the measurements here. We oftentimes help them with the data processing because they are not usually versed in this method itself. Since there's people coming here with vastly different materials that they want to investigate, I also get to know a lot of other materials that we research here. So I get to know a lot of researchers from all over the world. You get to exchange ideas and sort of talk to them how they work. I also get to co-publish with them in the research that they do, which is advantageous for everyone in the process. So there is a very wide variety of applications for neutrons in general, for positrons also. So positrons are very sensitive to defects inside of materials, and these defects are actually quite important for the hardening processes inside of aluminum. And we can investigate exactly these processes with positrons, and that's what I do in my thesis. And this application with positrons is also generally very interesting when it comes to semiconductors, because in semiconductors, you want as few defects as possible. We have close collaborations with other departments, for example, the engineering department, which also allows you to have some very close to industry research. Also, I don't only do material science, I also do a lot of programming, because typically you get a lot of data, but then you have to bring that data into a different form. And for that, nowadays it is absolutely essential to know programming language. Now I'm about halfway through my thesis, so 2 years now in, and I realized very quickly that this topic was very interesting, like investigating these aluminum alloys, but ideally you would also want to do some simulations to compare your results with some simulations to have an even better understanding of what's going on inside these materials. So then this also evolved where, okay, now I'm focusing a bit on simulations, and now I'm in this phase in the middle of my thesis where I really try to acquire a lot of data. I have about 1 year left to put all this data together into my thesis. I know that at the end of this year, I want to have most of the stuff for my thesis, and then I can concentrate on how to package it essentially for my thesis. Just like students have, like they have students representatives. I was the representative for my school, so the School of Natural Sciences. So I also put myself up for a vote of the Speaker of the Graduate Council. Other than the normal students at the university, where they have student representatives that are actually part of the voting bodies in the university, like the Senate or the school councils. As doctoral students, we don't have that kind of representation, but there are some other aspects that doctoral candidates have influence over. The Graduate Council is part of the graduate school. They lay the ground rules, and there we have actually representation, and we can influence some of the things that they decide, which is very good. We also do have twice a year actually a meeting with the president of TUM, where we can tell him some of our issues and some of our desires. I was elected in December, so you have to set some things that you can do in this year. And we have the lucky coincidence that this year TUM is applying for a new excellence initiative, and some of these things that we contribute there, for example, better supervision, may be picked up by the excellence initiative, which would be really good because that means that they are actually enforced by the university. But then we also do like more fun stuff. So we will organize like a larger party for PhD students later this year, TUM Blue, and there's also other events like workshops and stuff like that. In general, I think for your PhD, one of the things that you need is you need some sort of passion for the thing that you're doing, because the PhD can be very tedious, and for those phases it's really important that you still have like some sort of passion for the subject and for your topic. There's different aspects that motivate me for my work that I do here. When I have something that is unclear to me, I like drilling into that subject, finding out what's at the bottom of this. I also like that there's different aspects to my work, so it's very good for me that I can switch in between different things and have some sort of variety, so to say, in my work.